Hello, welcome back, everyone. I hope everyone had the time to grab the caffeinated beverage of your preference. Let's go ahead and get right back into this. Remember, with each one of these sessions, to click the Join the Discussion link. That'll take you to the Slack channel for each one of the breakout sessions that you're watching. It is my honor to introduce our next presenter. He was SpringSource employee #1. He's spoken at every Spring One. And as a personal note, he actually started my Spring journey. I don't know if he realizes this. Back in 2006, when I went to No Fluff Just Stuff, I listened to him speak about Spring, and that kind of kicked off my journey. Let me introduce Ben Hale in Spring to Image.
Thank you, Michael. I didn't know that. That's an impressive thing to have learned just now. Thank you, everybody. Welcome to Spring to Image. My name is Ben Hale. As Michael said, I'm a longtime Spring member, but these days my title is that I'm the lead of Java on Cloud Platforms for VMware. And this effectively means that my job for the last 7 years has been to ensure that Spring applications specifically, but Java applications more generally, run on cloud platforms. Obviously, when we were members of Pivotal, we were really focused on Cloud Foundry. As sort of the industry has changed, we've focused a lot more on Kubernetes these days. And so today I'm going to talk about some of the new features that we've added, some of the new projects that we're using to turn your Spring applications into images that can run on any platform, but probably Kubernetes these days. As Michael said, please feel free to jump into the Slack breakout session channel where I'll answer any questions that are left over when we get to the end after the formal Q&A. So when I think about the problem of getting applications to run on cloud platforms, it always sort of distills down to what it means to distribute an application in today's modern designs. As we see languages and frameworks proliferate within these development teams, we find it harder to treat something like an application artifact, a jar for Java developers, as the mutable artifact passing through systems. For many, many years, this was sufficient. You had, an artifactory or something like that where you'd store a bunch of jars and your CI/CD system would create and put them there. They'd pull them back down and go to deployment and stuff like that. But today, almost no one develops exclusively in Java, right? We all are Node developers or we're Go developers. We have a very polyglot kind of workflow. And a lot of those common languages that we're starting to look at are interpreted rather than compiled. The idea of having an application artifact, something that compiles down, isn't even always, sort of the right way to be thinking about a problem. We also have this issue that as developers have taken more control of their destiny, as DevOps has become a thing, developers, as soon as you are the person who's going to carry the pager and potentially have your evenings or vacation interrupted when something goes wrong, developers want to be able to test their applications in the environment that they're going to run in. And more importantly, they actually want to control the environment that their applications run in. They don't really trust other teams to configure it for them. Not because those other teams might not be good, but there's so much opportunity for a mismatch to happen between what you thought was happening and what actually happens in the real world. So that leads me to the following statement that's going to sort of anchor this entire presentation. Docker images, so OCI version 1, Docker version 2 images are the lingua franca for platform portability, right? No longer are we passing around jar images, we're passing around Docker images instead. So why do we like Docker images? Because Docker images become an immutable artifact that contain everything. They contain the operating system file system. They contain your applications file system. They contain the exact command that you want to start the application, and they become a self-contained environment. If you set an environment variable, you know that environment variable is always set, and it's always set to that particular value. There has not been another team who needs to read through an email or read through a playbook and guarantee that the environment is the way you want it to be, because you set it to be that. And that gives us this great advantage. It means that your application, your Docker image, runs exactly the same no matter where it is. Is it on your laptop like we'll demo today? Sure, great. Is it in a data center? Is it on a public cloud? Is it on a Docker daemon? Is it on Kubernetes? Like, where in the world might this application run, this Docker image run? It doesn't matter, because you can depend on that self-contained environment being identical. So now the most common way to create this Docker image, which we say is really good, is a Docker file, right? Everybody's really familiar with these. It'd be very, very difficult to be a modern application developer and not have seen a Docker file at this point. We're familiar with all of sort of the directives, the from, run, arg, things like that. And they're really good because they are so flexible. You can run any command you want. We see over in the example on the right, you can run apt-get, you can run curl, you can, run SHA-256 sum if you want to. That's really, really powerful. But that power, that flexibility also becomes a weakness for them. How do you guarantee that this is always consistent? How do you guarantee it's always secure? How do you guarantee that as soon as vulnerabilities are found, they're percolating through all of your applications in your entire enterprise? And it turns out it takes a lot of effort to write really good Docker files, right? What we're looking at here is simply 30 lines just to install a JRE in a reasonable way, right? This doesn't take into account like all of the infrastructure that sits around this to guarantee that you always have the latest version of the JRE, guaranteeing that any of the packages on that from line, that Ubuntu Bionic line, are being updated as soon as CVEs are posted and patches are available, which should then trigger this entire JRE to do. And then that, sort of feeds into what does it actually mean to get your Spring Boot application running or kept up to date as well. If you saw the very first session in this track today, where Brian and Stefan were talking about some of the improvements that Boot has made directly, if you use sort of their best case scenario, you're probably looking at 10 or 15 more lines of Docker file just to turn a boot jar as part of its build into a reasonable Docker file, and then hoping that it's kept up to date as all of the things underneath it, everything that it inherits from, continues to be updated. So the Spring team has decided that they're going to leverage a concept that we call build packs. So build packs were a thing that was originally invented by Heroku in 2011 and popularized by Cloud Foundry starting in 2013. And effectively, this is an alternate way to create a Docker image without using a Docker file. It's not sort of a Docker file generator or something like that. We actually generate Docker images. I'm going to have to make sure I keep that straight. Docker images sort of natively, right? And one of the key things about build packs, right? The best way to think about it is not as sort of the technical aspects of how exactly it does the work, but what it's doing is it's basically raising the abstraction, raising the value line, and we want to meet application developers where they are, at applications. When you write a Docker file, you talk about operating systems, right? The fact that you need to know the syntax for apt-get as a Spring Boot developer is like immediately a code smell, right? What we want to do is to give you the ability to give us an application, and we'll turn that application into that immutable artifact for you. We'll take care of managing the operating system. We'll take care of installing a JRE. You will take care of making sure that your Spring Boot application is ideally layered inside of an image. You focus on the application itself. So build packs, as I said, originally started at Heroku, were popularized by Cloud Foundry. And so we've actually started another generation of this, basically stepping back and saying those were sort of very specific to individual platforms. And while the idea is good, the technology wasn't sufficient for what we want. So there's a CNCF sandbox project called Cloud Native Build Packs. And this is a specification for how you turn an application into a Docker image, into an OCI image. It doesn't have any actual implementations of build packs. Different vendors provide those. So Heroku has a set of build packs. Google has a set of build packs. Microsoft has some build packs. But specifically, the Spring team leverages the Paketo build packs project. And these are implementations for the major language groups. So we have Java, obviously, but we have Node.js, we have Go, we have currently incubating some Python, some Ruby, PHP, there's an R build pack as well. And so all of these sort of major languages have implementations of this specification. But the key thing to take away from this isn't sort of some new fly-by-night project where we're all starting from scratch. The Paketo build packs are maintained by the exact same teams that always maintain the Cloud Foundry build pack. So everything we learned about running applications in cloud platforms over the last 7 years instantly translates into here. And you can trust the opinions that are expressed and the designs and the technology that are going into these Paketo build packs because we've been doing it a long time working with customers in real production situations. So let's jump straight into a demo here. So, as Josh Long likes to say, you should always start at the second best place on the internet, start.spring.io. We're going to just create a standard Spring Boot application here. I'm going to add a couple of dependencies so the application will actually stay started. So we'll add WebFlux because I'm kind of a reactive kind of person, and we'll add actuators. And that'll be good enough. Let's go ahead and create that jar file, or sorry, that zip file. Unzip that zip file. Go into there, and let's create our first image. Spring Boot has inside of it a Maven plugin. Gradle plugin exists for this as well, where we will leverage those cloud native build packs and the Paketo build packs to actually build us an image. I don't think I actually properly appreciated exactly how much you were going to see this beforehand. So if you've been watching any of the keynotes or any of the earlier sessions, I apologize. You're going to see once again Spring Boot build an image for us. So it starts by going off and doing a standard Spring Boot build, runs all the tests, something kicks out of it at the end, a jar file, and then that jar file is passed to the build packs. And what we see here, while it's off doing that, I'll interrupt the scroll a little bit. We see it go off and grab a bunch of build packs. There are 17 build packs. We'll explore a little bit more what all is in there. But the key thing is we have a Bellsoft Liberica build pack, an executable build pack, a Spring Boot build pack. Now, if we take a look at that, what did some of these build packs do? Well, the Bellsoft Liberica build pack comes in here and it contributes a JRE, right? We see it actually contributing the JRE after going off and downloading it, doing some other stuff. We'll talk in a little bit more depth exactly what's going on in here. Then it comes down and says, oh, this Spring Boot thing, this is an executable jar. It's got a main class inside of it. What command should I actually be off running? Here we go. We're going to run this, Java, and then the name of the main class. Finally, there's a Spring Boot application, right? I recognize based on some markers in here, whether it be jar files in bootinflib or whether it's entries in the jar manifest, hey, this is a Spring Boot application. And we can do Spring Boot specific things here, right? Like we can tell exactly what kind of web application this is because we know that this is a reactive web application versus sort of a traditional servlet web application. We can make some changes to what exactly goes on in here, right? So we see here kicking out at the end, we do some other stuff. A bunch of layers are created. There's one app layer in here. We paste some stuff, add some labels onto the outside of that thing, and there should be an image. We take a look now. I'm hoping that we will see this particular image currently in my Docker daemon. And we do. Demo 001 snapshot, right? What do we want to do here? Well, we said that images are completely portable, which means we can run them sort of on any platform that we want to. So how about this platform, my Docker daemon? So we'll do a docker run t, and what do we see? We see an application actually start here, right? Standard Spring Boot application, version 2.3.3 in this particular case, exactly what was compiled down there. We see it started Netty because I'm using WebFlux instead. And we see it go through and it does some stuff. And we'll talk a little bit, again, more about what this is. But you see, like anytime the build pack sort of contributes anything to your environment, we make sure to tell you exactly what's going on here, right? So we said that that the build packs have sort of very direct knowledge, very deep understanding of certain kinds of applications. Spring Boot, obviously, to me is near and dear to my heart. So what does it mean for us to understand Spring Boot? Well, as we saw in the Boot Loves Kubernetes talk earlier today, one of the things they've done is they've made it possible for you to layer your application inside of an image. This is basically taking what would be a normal Spring Boot exploded jar file. We automatically explode jar files because it is a significant performance increase to run applications that way. You shouldn't need to know that, but we need to know that. So what we can then do is say, hey, sort of the boot launcher can go on its own layer. It doesn't change very much, right? It only changes with each new version of boot. So we can probably reuse it and dedupe it. We can split your dependencies, right? Your specific application dependencies, because the versions of those dependencies probably only change, again, when you upgrade Spring Boot, or maybe when you occasionally add or remove a dependency, right? They're not changing every single time you build a new version of this jar file. So what do we want to do? We want to move that over onto its own layer, so that layer can be deduped inside of a registry. It can be cached out on edge nodes, things like that. And on, right? We can do this kind of thing. So the build packs, though, can understand that this is a boot application, understand the metadata there, and guarantee that your image is properly sliced like that. So let's go ahead and open pom.xml here. Right, okay. We're going to go in here. Let's see if I can freehand this. There's a configuration. There's a layers enabled. True. Layers configuration. And let's go ahead and do that same build again. This time, when we go off to build the image, we make sure that all of our builders are up to date. And you'll see that it actually built significantly faster this time. And the reason is the build pack is very, very good at reusing cached things that have not changed. We knew the JRE was going to be the exact same contribution that the JRE was before. And we said, hey, we're just going to use that layer. You don't have to download the layer to me. Like, we're going to use some OCI image layer features where we can just say, hey, here's a pointer to something you've already got up on the registry, right? And it was able to do all of that because nothing really changed. But what did change here is that now we can create application slices, we call them, but fundamentally they're layers inside of an OCI image. And we have one for dependencies, we have one for the Spring Boot loader, we have one for snapshot dependencies, and we have one for your particular application. The one most likely to change is the last thing that eventually shows up. So let's actually take a look at what that means. If you haven't seen it already, and you're going to start using Docker images a lot, the dive command is one of the most common things you're going to see. It's a great, really, really interesting under the radar kind of tool. And effectively what this is going to do is it's going to give us a view into the file system, each layer of the file system of an OCI image. Without logging into it, you don't need a shell or anything like that. Just shows you what's on the file. On the file system. So to start with, we've got the first layer, which is going to be the operating system layer. If we took a look at not what's changed, but what's on there, sort of exactly what you'd expect to see in an operating system. We put in a couple more things here, sort of installing certificates and things like that. But most importantly, we eventually show up and we start taking a look at the layers contributed by the build packs. So this Bellsoft Liberica build pack does a thing. It does some stuff with Java security properties. Eventually, we see it installs a JRE, and the only thing on this layer is a JRE. So you're probably going to get really aggressive deduplication, edge node caching, things like that already in your platforms, potentially across versions of your application, but across many different things. All right. If we go a little bit further, we're going to go ahead and see the application itself. So the first layer we see is the dependencies for your Spring Boot application, just sort of the non-snapshot stuff. We see the Spring Boot launcher as well. We see snapshot layer. There were no snapshots, but it'd be a thing likely to change. And eventually our particular application there. So we've sliced all of this stuff up onto a bunch of layers in a way that's completely optimal to guarantee, to the best of our ability, without having, deep intrinsic knowledge of your particular image, what can be cached, what can't be cached, what we can deduplicate, what we can't deduplicate, given really, really good optimizations there. So the Spring Boot, Maven, and Gradle plugins, as I said, are built on the Cloud Native Build Packs spec and the Paketo Build Pack implementations. They do a bunch of automated configuration. One of the things that you would have seen there is the name of the application, right? The image name is the application name. The image tag is the application version. Happens automatically for you, so you don't have to think about that. one of the really good demos, takes a little bit longer to do, so I'm not going to do it here, is it actually understands from your build system what version of Java you are targeting to use. So if you use Java 8, which is not the default in our build packs, Java 11 is. I highly encourage everybody to go to Java 11 if you haven't already. Nice and stable, tons of people using it, don't be afraid. But if you're using Java 8, it automatically sets the build pack configuration for you to guarantee that you get a Java 8 JRE installed, a Java 8 JDK installed if you need to do a build, something like that. All right, so that's what the Maven and Gradle plugins contribute. The build packs themselves go off and contribute that JRE, the command line, Spring Boot specific knowledge, things like that. So let's take a look at the next tool, another demo here. Let's get out of here. Good. So it doesn't take long really for you to, for a lot of people to sort of outgrow the Spring Boot Maven plugin. It's one way to work with it effectively. Putting the image creation inside of your application. But a lot of people actually like going in the other way, having another tool that's solely responsible for building your image that takes your application as input instead. And so we're going to use something called the Pack CLI. And the Pack CLI is created by the Cloud Native Build Packs project, and it is responsible for building applications for you. All right. So in this particular case, we're going to do that build. So it goes off and does a little bit of checking, making sure that I've got all the right images. I'm going to kick off one more thing here while we're waiting. So that's going to be waiting for us on the other side. All right, so it goes off and it does the exact same thing. I like Pack because I like the colors better, mostly. But fundamentally, we're driving the exact same behavior, the exact same build packs, the exact same lifecycle, downloading the exact same things. In this particular case, we're giving it source code, so it's downloading a JDK and installing that, and it's going to build from source. So while that's going on, I want to talk a little bit about what exactly we're seeing here. So on the Paketo build packs, one of the key things that'll help you really get started with them is all the configuration that you might set for a build pack. You don't have to go to the documentation. I encourage you to go to the documentation if you want more, but we tell you, right? You can set an environment variable, BP JVM version. Here's what the default is, or here's what it's currently set to. You can override that and set that to 8-point-star. You can set Java tool options if you need to do, GC flags, or you need to set memory flags, things like that. All of that configuration is available to you. We can take a look at some of the other things that we contribute. So for example, we contribute an active processor count helper. It turns out that JVM has a lot of trouble figuring out in containerized environments how many processes are actually available to it. We help you along with that. Link local DNS is us taking a look and saying, hey, if you're running in a Kubernetes system, the DNS is close. And because the JVM's DNS isn't very good, especially in highly dynamic environments, we're going to do some work to tweak that for you. The memory calculator is one of our most important contributions. Running a JVM inside of a container with its 6 memory regions is really, really, really tough. But we do some analysis of the application you've given us, what we know about JVM defaults, what you have configured as Java ops, and we will calculate the optimal memory configuration for your particular application. And it goes on and on. We contribute those kinds of things. We allow you to configure how exactly your Maven or Gradle build or SVT or Lineagen builds are going to go as well. So all those, eventually kick out into an image, right? So we said Pack is basically doing the exact same thing, but it sort of inverts stuff, right? It says, we're going to run your build for you. We do a bunch of things around attaching metadata like Docker image labels, including Spring Boot's configuration metadata. We also have the ability to include a bill of materials. So you can use the Pack CLI to inspect images and take a look at, hey, what version of the JRE went in here? What version of JVM killer, the memory calculator went in? But you can also ask the question, what version of Jackson is in here? What version of Spring is in here? That information metadata is included as well. Build packs are also modular, so you can do things like swapping out a JRE or a bunch of other things. So you can do a pretty quick and easy thing to say, instead of Bellsoft Liberica, I want to use Adopt OpenJDK, or I want to use Azul Zulu, or I want to use Amazon Corretto or something like that. All of that stuff can flip through as well. The final thing I want to show everybody is something that we call KPAC. And KPAC is effectively a Kubernetes native platform that does this same kind of stuff. So when we take a look at this, it gives us the ability to basically say, hey, here's a builder, right? Here is a CRD or a resource definition that defines a builder. That builder says, I want you to build using the Paketo build packs Java. And what I want you to do is go watch this particular source, so nebhail demo.git, at a particular branch. I want you to create this image on Docker Hub, and I want you to use this builder to do it. And now KPAC is effectively going to watch if the stack, the underlying operating system changes, if the build pack changes, or your source code changes, it's going to go off and do a build automatically. And it doesn't look like I saw that. Oh, it's image YAML. Oh, well. So that's not going to get done before I get there. Maybe I can trigger it real quick and we can take a quick look at it. So this has gone off. As soon as this image comes into existence, we see that a pod kicks off. It goes off and says, hey, let me go find out which build packs are actually going to run. Let me get everything started. And then let's go take a look at this build that's happening right here. And so inside of a Kubernetes container, we're seeing the exact same build happen again. So not only are Docker images something that are totally portable across platforms, even this entire cloud-native build pack system and the build packs associated with it, portable across a bunch of different platforms. This is going to build the same image, and it's just going to effectively, because it's watching for changes to your source code, just create a stream of images. Every time you commit, a new image shows up on a registry, individually tagged so that you can figure out which one is which, as well as having a latest tag if you just want to track a mutable tag from there. So that KPAC thing uses the exact same foundations as both the Maven and Gradle plugins and the Pack CLI. It is vanilla Kubernetes compatible, and it's effectively a different way of looking at the problem, saying here is a declarative configuration pointing at build pack stacks, sources, and jars, automatically creating that stream of images. So Docker images are the lingua franca of platform portability. Docker files can create them, but they've got some day two issues. I'm happy to talk about those in the Q&A and the Slack channel for hours if you want. Build packs provide an application-oriented abstraction, right? So we can build them from a bunch of different places, and we provide a lot of goodies, JDKs and JREs, command lines for multiple deployment types, queryable image labels, and a bill of materials. So your security team can find out exactly what's in your images really, really easily. So with that, thank you all. You can find me on Twitter at nebhail. You can find me as well in the Spring Session to Image channel shortly. We're going to do the Q&A first.
That was amazing. A ton of really valuable information for everybody that's working with Kubernetes and Docker-based images. And Ben just volunteered to speak on Slack for hours, so take him up on that. Click the join the conversation link and keep him there for hours, please. We're going to take a quick 5-minute break. Don't go too far. Up next, we'll have Alexei speaking about Spring, your next Java micro framework.